Separating solid/liquid mixtures. Solubility. A solution is formed when a solute is dissolved in a solvent. Solute, this is a substance that dissolves in a solvent forming a solution. Solvent, this is a substance in which a solute dissolves forming a solution. Solution, a uniform mixture which is formed when a solute is dissolved in a solvent. Dilute solution, a solution with a small amount of solute/DM3. Concentrated solution, a solution with a large amount of solute/DM3. Concentration, the amount of solute, in grams or moles, that can dissolve in 1 DM3. Saturated solution, a very concentrated solution with the maximum amount of solute that dissolve in it already dissolved in it. Of a solvent. If you leave a hot saturated solution to cool, crystals of the solute will form. This is because as the temperature decreases, the solvent can hold less solute, so excess will form in the form of crystals. The rate of dissolving can be increased by increasing temperature, more stirring, crushed solute, larger surface area. Solubility, the maximum amount of solute that can dissolve in 100 g of water at a particular temperature. If we want to find the solubility of table salt, sodium chloride, at 30 oC, we do follow these steps. Solubility increases as temperature increases. This is because the intermolecular spaces between the water molecules increase with temperature, giving more space for the solute's molecules. Use a balance to measure 100 g of water accurately. Pour the 100 g of water into a beaker. Heat the water to 30 oC using a Bunsen burner and a thermometer. Using a spatula, add a considerable mass of the table salt into the water and stir. If the mass of salt dissolves completely, add the same amount again and stir. Repeat this if the mass keeps dissolving completely until you start seeing excess of the salt not dissolving at the bottom of the beaker. You have to record the masses of salt you are adding each time, and when you start seeing the excess, stop adding salt and sum up the amount of salt you added. Call this mass 1. Filter the solution. The excess of salt will be the residue, dry it and weigh it. Call this mass 2. The amount of table salt that was dissolved in water is mass 1, mass 2. This is the solubility of table salt at 30 oC. Solubility increases as temperature increases. This is because the intermolecular spaces between the water molecules increase with temperature, giving more space for the solute's molecules. By evaporation, for soluble solid/liquid solutions. Put solution in a beaker. Set the apparatus, tripod with a gauze above it and a Bunsen burner below it. Put the beaker on the gauze. Start heating the solution. Slowly the liquid will evaporate completely, leaving the solute behind in powder form. By crystallization, for soluble solid/liquid solutions. Put solution in a beaker. Set the apparatus, tripod with a gauze above it and a Bunsen burner below it. Insert a glass rod in the beaker. Turn on the Bunsen burner and continuously dip the glass rod in the solution. When you see crystals of the solute starting to form on the glass rod, turn off the Bunsen burner. This is crystallization point. Leave the solution to cool. Filter the solution and take the crystals, which will be the residue. Wash the crystals with distilled water, then dry them between 2 filter papers. Do not dry the crystals in the oven because it will evaporate the water of crystallization, turning it into powder. By simple distillation, for soluble solid/liquid solutions. Set the apparatus as shown in the diagram below. Turn on the Bunsen burner. The solvent will evaporate and rise as vapor into the condenser. The cold water surrounding the tube where the water is in the condenser will make the vapor condense into liquid. The solvent is collected in the tube or beaker on the other side of the condenser. It's called the distillate. The solute is collected in the flask as powder. The thermometer must be where the vapor passes to measure the boiling point of the solvent. This method is perfect for distilling seawater. Filtration, for insoluble solid/liquid mixtures. Set the apparatus as shown in the diagram below. Pour the mixture into the filter funnel. The solvent will go through and be collected in the beaker as the filtrate. The insoluble solid will be collected from the funnel as the residue. Decantation, for insoluble solid/liquid mixtures. This method is very simple. It involves letting the insoluble solid rest at the bottom of the beaker. Then pouring the liquid in another beaker, leaving the solid behind. Centrifugation, for insoluble solid/liquid mixtures. Put the mixture in a test tube. Place the test tube in the centrifugation machine. Start the machine. The centrifugation force will make the mixture separate into two layers, the liquid at the top and solid at the bottom. They are then separated by decantation.